Okay, so we're going to do some coordinate geometry proofs. That means if we have some 4 points on a graph and we connect the 4 points, it makes a quadrilateral. We want to prove what kind of quadrilateral it is. So is it a square? Is it a rectangle? Is it a parallelogram? So we're going to show that its definition, one way to do it is to show that its definition is true. So, for instance, if we wanted to show that this thing was a parallelogram, we would show that the opposite sides are parallel because that's the definition. Both sets of opposite sides parallel. If we wanted to show something was a rhombus, we have to show that all the sides are congruent, and so on and so forth. So to do that in coordinate geometry, the way to show segments congruent is with the distance formula. The way to show that segments are parallel, that's with the slope formula. If we want to show a rectangle, we want to show that segments are perpendicular so that we can show that it's a right angle. And when we have all right angles, we know we have a rectangle. So the way that we can show that line segments are perpendicular is also using the slope. So before we can go do all that, we have to talk about these formulas: slope, distance formula, okay? So so first for slope, it says we use slopes to show, I'm going to speak specifically about proving quadrilaterals, to show that opposite sides are parallel and adjacent sides are perpendicular. I'm out of space. Oh no, Siri, get out of here. All right, are perpendicular. And you should be taking notes along with me as we go here. So parallel lines have equal slopes. So that's how we're going to use slopes to show that. If we take the slope of each line segment or each side, they should be equal. For instance, if one side, the slope comes out to be a half, and then I do the slope of the opposite side and I get a half, then I know they're parallel. If I got a half on one side, but then on the other side I got negative 1/2, those are not equal slopes. Sorry I keep hitting the home button. Those are not equal slopes, meaning the lines are not parallel. Okay, that's what that means. Perpendicular lines have slopes, I'll say have opposite reciprocal slopes. So for instance, I'll go back to my 1/2. If one of the sides has a slope of 1/2 and the adjacent side has a slope of -2/1, then those would be perpendicular lines. I would know that that's a right angle. Let's look at the opposite part. Opposite means that one is positive and one is negative. So that's the case, right? One slope positive, the other slope is negative. So that's the case here, right? The reciprocal part means that we flip them. If I have 1/2, then the other one would be 2/1. And keep in mind that it's probably not going to be expressed as 2/1. They would write it like that. Those are opposite reciprocal slopes. Also keep in mind that you may see something like this. Those are also, if I make that one, nope, sorry, those are not opposite reciprocals. I want to make this one negative, and I'll make it, those are also opposite reciprocals. They might not look like it at first. You have to reduce your fractions. And then, so if I reduce 2/4, I get 1/2. If I reduce -30/15, I get -2. So that's how you use slopes to decide if if sides are parallel or if sides make 90-degree angles. What's the formula? You'll recall that the slope formula is, a lot of you call it rise over run. We also said it's the change in the y coordinates over the change in the x coordinates. We do that by subtracting. That's how we get a change. Also remember these 2's and 1's. It doesn't mean y squared. It's just saying the y from your second point. So there's your slope formula. For distance formula, we use distance formula to show that sides are congruent. The distance formula shows that sides are congruent. So a reminder of the distance formula, if you want to find the distance between 2 points, you subtract your x's and square them, plus subtract your y's and square them. And that's how you get the distance between 2 points. You'll recall that this was really Pythagorean theorem, like that's a leg and that's a leg. When we subtract the x's, we're really finding the length of a leg, and we subtract the y's, we're finding the length of another leg. So that if I wanted to find the distance between these 2 points, I would really turn it into a right triangle. When I subtract the x's, I get this leg here because it runs in the x direction. I'll get that length. And when I subtract the y coordinates of those points, I'll get that leg there because that's going in the y direction. And then I'm basically just doing Pythagorean theorem. Just a quick refresher on that. Midpoints. We use the midpoint to show that a diagonal is bisected, or where a diagonal is bisected. So line segments that have the same midpoint, like the diagonals, we will say they bisect each other. That's a property that we're going to have to show sometimes, or we can show, or we might not have to. So when they have the same midpoint, that means they're both cutting each other in half. Again, if I have 2 points, the midpoint is the point right in the middle. That means it cuts it into 2 smaller congruent parts, line segments. Then if I had another segment that has the same midpoint, if they have the same coordinates, then I know that they bisect each other. Each one of those segments cuts each other in half. That's what we're sort of saying here. The formula for that is you average your x coordinates, and that gives you your x coordinate in the middle. You average, because it's a point, right? So you need an x coordinate and a y coordinate. You average your y coordinates, and that's the y coordinate of the point in the middle. Keep in mind, these are just averages, right? That's the average of your x coordinates, and that is the average of your y coordinates. How do you find the average of two things? Well, if you got an 87 on a test and then a 94 on another test, you would add those two together and divide by 2, and you can see that's what's going on in each one of these formulas. Those are the tools that you're going to have to use.